Hello everyone, today we are going to start our new lesson, lecture number 4, calculating moles of gases, and it is related to our previous lecture that was moles in terms of volume, okay, and it still continues. So we have stated that usually the unit volume is used for measuring the amount of gases, okay. So in this lecture we will discuss how we calculate the volume of gases, okay. So when we have studied, let me remind that amount of any substance, okay, that there is a given amount of any, so that 1 mole of any substance, 1 mole of any substance, that substance may be in the form of molecule, compound, ions, charge, whatever, it is equal to the 6.02 into 10 raised to power 23 particles, okay. Particles, these particles may be atoms, charges, or these particles may be molecules or compounds. Is that clear? In the same way, as we know that from gases point of view, okay, whenever we are talking about gases, we know that gases are being measured through volume, okay. So we have to calculate them. We have to consider calculation of gases from the perspective of volume. So 1 mole of any gas, okay, which 1 mole of any gas have volume of 24 decimeter cube, okay. 1 mole of any gas have a volume of 24 decimeter cube, and this 24 decimeter cube have what the number of particles? 6.02 into 10 raised to power 23 particles of gases. Is that clear? And keep in mind that gases, they are usually in the form of molecules. These are maybe diatomic molecules or triatomic molecules or tetraatomic molecules, but some gases they are also formed in the form of atomic state, like that of noble gases. Noble gases, they are found in the form of atoms, not molecules or gases. Is that clear? So 1 mole of any gas consists that specific amount of volume, and this specific amount of volume, that is 24 decimeter cube, have this specific amount of particles, okay. Keep in mind this 24 decimeter cube that I'm talking about, this refers, this is we calculate this 24, we consider this 24 decimeter cube when the temperature and pressure is specific, okay. The specific temperature is called room temperature and pressure. Room temperature and pressure, usually written in your book as RTP, sometimes also called STP, standard temperature and pressure. The standard temperature and pressure, standard room temperature is 25 degrees centigrade and pressure is 180 atm, okay. So whenever the temperature is 25 or room temperature and pressure is 1 atmospheric pressure, 1 atmospheric pressure is the pressure that we humans, we all living organisms are living, the surrounding pressure that you can feel surrounding you, this is the pressure, okay, that you can live, this is the pressure, okay, and this is 1 atmospheric pressure, okay. And keep in mind this 1 atmospheric, 1 atm, 1 atm is equal to 10 raised to power 5 Pascal. Is that clear? So 25 degrees centigrade of temperature and 1 atmospheric pressure is the standard units, is the standard. These are the standardization that are being used for calculating the moles of gases, and usually the volume at this temperature and pressure is taken as 24 degrees centigrade, having particles of this amount, okay. So now coming towards the formula of moles, the moles of gases the formula, the relation is equal to volume divided by 24 decimeter cube. Okay, this volume must be given in diameter cube. So volume in diameter cube is divided by 24 decimeter cube. This is mole, usually denoted by N. So N is equal to V in diameter cube divided by 24 decimeter cube. This is the relation that is usually used for calculating the amount of, calculating the moles of gases at RTP or STP. Is that clear? So now let's come towards solving the questions. There is a table given in your book that consists of volume of gases, moles of gases, and mass of gases. Okay, for example, phosphorus trihydride, or also sometimes called phosphine, pH3. Its volume is given. Okay, the volume is in centimeter cube. That is 80 centimeter cube. Okay, definitely I have to convert them into decimeter cube. So the volume will become 0.08 decimeter cube. Why? Because I divide this value with 1000 and it comes out to be 0.08 decimeter cube. Mass of, you need to find the moles of the gas and mass of the gas. Okay, so definitely we can find the moles of phosphine gas, that is equal to given volume. Given volume is 0.08 decimeter cube divided by 24. If I divide this value with 24, it will comes out to be 0.08 divided by 24. So it will become 3.33 into 10 raised to power minus 3 moles. Okay, so in the second mass of the gas you have to find. Okay, molar mass. Okay, mass in gram. Okay, not, you have to find the weight of pH3. Definitely we have found the moles. So formula for, we know that moles is equal to weight divided by molar mass. So weight is equal to N multiplied by molar mass. In this case, what will weight, gram weight would become moles. These are 3 into 33 multiplied by 10 raised to power minus 3 multiplied by molar mass. Molar mass of phosphorus is, we know the atomic number, mass number of phosphorus is 31, and 3 hydrogen, 31 plus 3, 34. Okay, so 34. So this will be multiplied by 34. We will get weight of phosphine gas would become 0.113 gram. Is that clear? In the same case, you can also find sulfur dioxide. Okay, sulfur dioxide, only weight is given. Weight is 8 gram. So you can find the moles very easily. 8 divided by sulfur is 32. Mass of sulfur is 32 plus 2 oxygen atoms. 2 multiplied by 16. That becomes 8 divided by 64. 64. It comes out to be, so number of moles it would become 0.125 moles. Okay, so moles of the gas would become 0.125. Is that clear? Now again, the volume becomes very easy. We know that V over 24 decimeter cube. So the volume, it becomes moles multiplied by 24. .125. So the volume becomes 3 decimeter cube. Okay, the same way you can also find the volume of oxygen. Only moles are given very easy. Through moles you can find gram, and through moles you can also find the volume, very easy. So another question which is given in your book is that sodium carbonate react with 2 mole of hydrochloric acid and 2 mole of sodium chloride plus carbon dioxide and water is given. So how many moles of carbon dioxide are produced when 0.2 moles of sodium carbonate reacts with excess hydrochloric acid? So now coming towards the solution, the moles of carbon dioxide are produced. So you need to find the moles of carbon dioxide, okay? And when 0.2 moles of sodium carbonate, so the moles of sodium carbonate, these are 0.2. Okay, definitely you can apply over here mole concept. Applying mole concept, so the moles of sodium carbonate divided by its stoichiometric coefficient is equal to mole of carbon dioxide and stoichiometric coefficient. So the moles of sodium carbonate is 0.2 divided by stoichiometric coefficient is 1, and mole of carbon dioxide is asked in the question, so we will put x value, and carbon dioxide is also 1. So here x is equal to 0.2 moles of carbon dioxide. Okay, so then calculate the volume of this number of moles of carbon dioxide at RTP. So definitely we can calculate the volume of carbon dioxide very easily. Okay, so it would become moles which are equal to volume, given volume, and divided by decimeter, 24 decimeter cube. So volume becomes moles multiplied by 24, and moles are 0.2 multiplied by 24. Volume of give 0.2 multiplied by 24. It comes out to be 4.8 decimeter cube. Okay, so here again you can apply mole concept in order to find the stoichiometry, in order to solve the stoichiometry of the equation. Okay, again there another question number 7. Equation is given ammonium nitrate. When we heat ammonium nitrate, sodium oxide, nitrogen oxide, and water is produced. So how many moles of ammonium nitrate are present in 0.8 gram of the solid? So you need to calculate the mole of ammonium nitrate. Definitely we can do this through dividing weight of the substance by its molar mass, and weight is given, that is 0.8 gram. Molar mass, we will now that nitrogen mass of nitrogen is 14. How many nitrogen? There are 2 nitrogen. Plus how many oxygen? 3 oxygen, 16. How many hydrogen? 4 plus 4. So moles would become 0.8 divided by 14 multiplied by 2 plus 3 multiplied by 16 plus 4. It comes out to be 80. So 0.8 divided by 80 comes out to be 0.01 moles. These are the moles of ammonium nitrate. So what volume of nitrogen oxide gas would produce from this mass of again part C needs application of mole concept. So through mole concept you can find the unknown moles and unknown amount of the substance. So mole of the ammonium nitrate divided by its stoichiometric coefficient is equal to mole of which substance? Nitrogen oxide divided by stoichiometric coefficient. Here mole of ammonium nitrate is 0.01 divided by 1 is equal to mole of nitrogen X. It's also 1. So mole of which nitrogen oxide comes out to be 0.01 moles as well. Now you can easily calculate in the second step volume of nitrogen oxide, that you can multiply number of moles through 24 decimeter cube. Okay, so number of moles which are 0.01 multiplied by 24, it comes out to be 0.24 decimeter cube of nitrogen oxide. Is that clear? So you can apply stoichiometric concept or mole concept by finding the unknown mass of the reactant or product. This question in your book on page 23 again, that ammonia reaction, two type of gases, that is ammonia and hydrochloric acid, react together to form ammonium chloride. Solid is formed. Okay, calculate molar mass of ammonia, hydrogen and ammonium chloride. Very easy. You can calculate hydrogen. Chlorine is 35.5 plus 1 hydrogen, it will becomes 36.5 hydrochloric acid mass. Okay, again ammonia, NH3. Okay, mass of nitrogen is 14. There is one atom of nitrogen, plus mass of hydrogen is 1, and there are 3 atoms of hydrogen. So 14 plus 3, 16. Okay, and then again ammonium chloride. Okay, one mass of nitrogen is 14, 1 atom of hydrogen plus 4 atom of hydrogen plus 1 atom of chlorine, 35.5. So 14 plus 4 plus 35.5, it comes out to be 53.5. Part C, very easy, they very critical. Now, what volume of ammonia and hydrochloric acid must react in order to produce 10.0 gram of ammonium chloride? 10.7 gram of ammonium chloride is given. Okay, so first of all, again we have to find the moles of hydrochloric acid and ammonia. In the first step, we can find the moles. First of all, we have to convert the gram weight of ammonium chloride into moles. And after conversion of gram weight of ammonium chloride into moles, we will apply the stoichiometric concept. After applying the stoichiometric concept on both hydrochloric acid and ammonia, we will be able to get the value of ammonium and chloride. And the last step, we will be able to convert moles of both this hydrochloric acid and ammonia into gram weight. Now, in the first step, we will convert gram weight of ammonium chloride into moles. So is equal to gram over weight, gram over molar mass. So 10.7 gram over molar mass of ammonium chloride is 53.5. Now moles of ammonium chloride comes out to be 10.7 divided by 53.5, 0.2 moles. Okay, so we will apply mole concept for each of the reactant separately. So apply mole concept for ammonia. Okay, so mole of ammonia divided by stoichiometric coefficient is equal to moles of ammonium chloride divided by stoichiometric coefficient. So let us see whether the equation is balanced or not. 4 hydrogen over here, 4 hydrogen over here, 1 nitrogen over here, 1 nitrogen is also there. Chlorine is 1 there and also chlorine. So there is no need to balance the equation. So mole of ammonia, which is X divided by 1, and mole of ammonium chloride is 0.2 moles divided by stoichiometric coefficient 1. So X comes out to be 0.2 moles of ammonia gas. Is that clear? Is that clear? So I hope that you are getting the question. The same way we will have to apply the mole concept separately for this hydrochloric acid. Concept for HCl. Okay, which are mole of HCl divided by stoichiometric coefficient divided by mole of ammonium chloride divided by stoichiometric coefficient. So X divided by 1 is equal to 0.2 divided by 1. X, that of HCl, is equal to 0.2 moles. Got it? Now you can easily, in the last step, in the third step, this was second step, okay? In the second step we've applied mole concept. In the third step you can find the weight of ammonia gas. We know that mole of the ammonia gas was 0.2. So what will we do? We will multiply weight over molar mass. Okay, we will multiply weight number of moles multiplied by its molar mass. So moles, which was 0.2, multiplied by molar mass of ammonia. Here we find out that it is 16. So 0.2 multiplied by 16 comes out to be 33.2 gram. Okay. In the same way, we can also find the weight of HCl by multiplying its moles with molar mass. Okay. So mole of HCl was also 0.2, and its molar mass, as we have calculated in the part B of this question, it was 36.5. So 36.5 will get multiplied with 0.2, that is 7.3 gram. Is that clear? So in this way we can also apply mole concept for finding the unknown mass and unknown moles of the reactants or even products. I hope that you have understood calculating moles or calculating volume of gases when the temperature is specific, that is 25 degrees centigrade, and pressure of that of 1 atmospheric pressure. In the next lesson we will study that when temperature increases or decreases, what will happen. So we will find it through another relation, that is PU is equal to nRT. Okay, this is also called general gas equation. Okay, and this is used when the temperature is not specific, when we have variable temperature, when the temperature is below or above 25 degrees centigrade, or when the pressure is above or below 1 atmospheric pressure. Okay, so we will use this relation. Okay, and we will calculate, we will do numericals through this relation as well. So I hope that you have understood the question, and let me give you a homework. Your homework is that calculate the volume in decimeter cube occupied by 26.5 gram of carbon dioxide at RTP. The atomic mass values of carbon is 12 and oxygen is 16. You need to calculate the volume. Part B of this question says that a flask of volume 120 centimeter cube is filled with helium gas at RTP. Calculate the mass of helium present in the flask. So you need to find the mass of helium in the flask. Okay, so this is your homework, and if you have successfully done the question, you can answer you can message the answers in the comment box. Okay, so I hope that you have understood the concept.